Hi, welcome to Help Sessions video. We're going to be covering stoichiometry and the molar map today. The molar map is a tool to help with conversions and reactions that you have to do between grams or moles or atoms or moles to moles, and it's a visual representation of what's needed to be done to be able to go from one unit to the other. So first we're going to draw it out. So we're going to first assume that we have two different compounds. So we're going to have compound A, and then we're going to have in a different color, slightly different color, compound B. Okay, B. And so for compound B, you have moles. Moles is the highest level unit that you can have for a specific compound that allows you to go to other different compounds. And so within moles you have mass, you have atoms, and then within atoms you have 6.022 times 10 to the 23rd, and then you have for mass you have grams, and then you have kilograms, and you can convert in between them. And it's the same thing for compound A. So you have moles, and then you have mass, and then you have atoms. Atoms again are 6.022 times 10 to the 23rd, and mass is in grams or kilograms, and you can convert in between them. And there's a link between these two compounds that is called the molar ratio. And so the molar ratio is the ratio between them in a reaction. And so we'll see an example here in a second about this. So when you have moles of one compound, you can go to the mass of that compound and then atoms. When you say a mole of something, you want to think just kind of like a dozen. When you have a dozen of something, you have 12. When you have I guess a baker's dozen, this is the only thing I can think of. A baker's dozen, you have 13. If you didn't know, you have 13 in a baker's dozen. Well, when you have a mole, you have 6.022 times 10 to the 23rd of something. So this is really what mole is doing whenever you say you have a mole of something. You have this many of that. And so say I have a mole of O2. When I say I have a mole of O2, that means I have this, O2 is a molecule, and I have that many molecules in one mole of it. So I have 6.022 times 10 to the 23rd molecules of O2. That's really what you say when you have one mole of something. Mole isn't short for molecules. Mole is 6.022 times 10 to the 23rd of something. So that's what you're saying. When you have one mole of O2, you have that many molecules. And it's for anything. So if I said 1 mole of hydrogen or H2, I have that many atoms of hydrogen or that many molecules of H2. So that's really what you want to understand with moles. And so let's have an example problem here. Let me see if I can erase most. I can't erase all of it. What we're going to be doing here is I'm going to have an example reaction where we're going to use this map and understand why it's helpful to understand this visual representation of it. So, okay. So say we have the reaction. Let's create a line between them. We're going to have another color. Let's see, red. I like red. We're going to have the reaction H2 plus O2 becomes, as we all know, H2O. Now the first thing you want to do when you have a reaction is you want to make sure it's balanced. So we're going to have 2 here, so we have 2 oxygens, and then we're going to have 4 hydrogens on this side, so we need to put a 2 in front of this H2. And then this is balanced. So then we can continue. So say I have 5 grams of O2, and I have an excess amount of H2. And so this means that O2 is going to run out first. I want to know if I have 5 grams of O2, how many grams of H2O will I produce? So what we want to start off here is we want to figure out where we are on the map. So we have 5 grams of O2, so that we know that we're starting off, if O2 is considered compound A, we're starting off within the mass part. We're starting in the grams part of mass. And so to go from however many grams of O2 we have to however many grams of H2O we're going to have after the reaction occurs, we have to go from grams of O2 to moles of O2, use the molar ratio to go to moles of H2O, and then the grams of H2O. So we're going to write out what's given. We're going to have 5 grams of O2. And then what we want to do to cancel out the units of grams of O2 is to multiply by the molar mass. So the molar mass is really just how much O2 weighs. So O2 is 16 times 2, because an atom of oxygen weighs 16 grams when you have a mole of atom, or a mole of oxygen is 16 grams when you have O2, and when you have O2 you just multiply that by 2. So we're going to have 32 grams of O2 per 1 mole of O2. And so what this does is when you divide by the same unit, you actually cancel out the unit. And so what you're when you're left with, once you evaluate this small expression here, is that you're left with 5 moles of O2 divided by 32. And then you'll find out how many moles you have in 5 grams of O2. We're going to keep going though. We're going to multiply by the molar ratio, as you see above in this line here. And we're going to figure out what the molar ratio is. So the molar ratio here is however many of one molecule or compound that you have per the other molecule. So we can see that we have, for every 1 mole of O2, we have 2 moles of H2O. It's a 2 there, and there's an imaginary different color for this. There's an imaginary 1 here. So it would be this 1 and this 2. And so the molar ratio would be 1 mole of O2 per 2 moles of H2O. So we're going to write that down here, and we want to keep in the same line of thinking. We're canceling out units to get to the unit we want. So we're going to write 1 mole of O2, 1 mole of O2 on the bottom, so we can cancel out the moles of O2. I'll do that now. And then we're going to have 2 moles of H2O on the top. And what we're left with is 5 multiplied by 1 multiplied by 2 moles of H2O divided by 32 multiplied by 1, which just leaves us with the unit of mole of H2O. And so now we're here. Now we're here, because H2O is compound B, and O2, that's an O, that's O2 for compound A. And so now we're here in the moles of compound B. But the question that I proposed to us was, how many grams do I have? And so again, to find out how many grams we have to cancel out the unit of moles of H2O. So what do? We'll multiply by the molar mass. I knew you knew that. Moles of H2O, we have 1 mole of H2O, and in 1 mole of H2O we have 16, because that's the atomic weight of oxygen, plus 1 times 2, which is the molar weight of H2O. And so in 1 mole of H2O we have 18 grams of H2O. And so we see that these two cancels out because they're on opposite sides. They have to be on if one's on the top, the other one has to be on the bottom for them to cancel out. You can't multiply across with the same unit. It just doesn't work for this type of analysis. This is called dimensional analysis, and it doesn't work if you have the units on the top and also on the top. They have to be on the top and the bottom. And then we're going to evaluate this in total. And so this, when I use my calculator that I have here, 5 times 2 times 18, and we're going to divide that by 32, we get 5.625. So let me write that down here. 5.625 grams of H2O. And so what this is saying is that after all of this reaction occurs and we put in 5 grams of H2O, it's going to produce 5.625 grams of H2O. And when we look at where we are here, we actually see that we've gone from the grams here to the moles of compound A of O2. We went through the molar ratio. We went to compound B, where we have 4 moles. Step 4 was moles of compound B, and then we went to here, the mass of compound B, and we're at step 5. It's fairly short, the steps you have to take to do it. And then you get to 5.625 grams of H2O. And so this would be a sufficient answer if they asked how many grams of H2O, how many grams of H2O do you need, or how many grams of H2O is produced when you put in 5 grams of O2 into this reaction. because all this reaction is saying is that for every 2 moles of H2O, or 2 moles of H2O will combine with 1 mole of O2 to produce 2 moles of H2O. And so this is just kind of like the ratios that you need for this reaction to occur. But if you put in your own amount, then you can find out how much is produced by that amount. And so say I wanted to know if 5 grams of O2 was put into this reaction and I got 5.625 grams of H2 out, how many grams of H2 did I use? So the way you would do this is you'd want to go back the same way we did. So we're going from, we're going to make compound A now. We're going to make compound A, I'll do this in a different color. Compound A now is going to be H2O, and compound B is actually going to be H2. See, because I asked, we wanted to figure out how many grams of H2 went into the reaction to produce 5.625 grams of H2O. So now we're going to have a separate section here, separate section, and then we're going to find if we have 5.625 grams H2O, we want to cancel out the units for grams to H2O, so we're going to divide by the molar, or we're going to multiply by the molar mass and have the grams on the bottom. So it'd be 18 grams H2O, we calculated this earlier, per 1 mole of H2O. We're going to multiply by the molar mass between them. So for every 2 moles of H2O, we have 2 moles of H2. So this is technically just 1/1, but I'll write it out anyways. So we want to cancel the units. 2 moles H2O per 2 moles of H2. And then we want to multiply by the molar mass of H2 to cancel out the moles. So we're going to have per 1 mole of H2O, since the molar mass is per 1 mole of whatever that molecule is, we have 18 grams, right? Oh, I apologize. H2. So per 1 molecule of H2, you have 2 grams of H2. You evaluate this out, and you find 5.625 times 2 times 2 divided by 18 times 2, you get 0.625 grams. 0.625 grams of H2 put into the reaction. And so we know from this tree, which visually demonstrated what we were doing, is that if we put in 5 grams of O2 into this reaction here, you will come out with 5.625 grams of H2, and you will use up 0.625 grams of H2 to produce 5.625 grams of H2O if you put in 5 grams of O2. This can be any sort of problem. You just have to change the numbers around and make sure you're following the correct steps. So if you have atoms, if you have the number of atoms, let's find that out. Let's find out how many atoms we have in let's say 5.625 grams of H2O. So we know we have 5.625 grams of H2O. We're going to multiply by the molar mass, because we can only go, as you can see from the map up here, you can only go from moles to something else. You can only go from moles to grams, or to mass, or from moles to atoms, or from moles to moles, but you can't go from mass to atoms. You have to convert through moles. So we're going to multiply by 18 grams of H2O per 1 mole of H2O. And since we know that in 1 mole of H2O, or 1 mole of H2O, you have 6.022 times 10 to the 23rd atoms of H2O. If you evaluate this out, you'll find the number of atoms in 5.625 grams of H2O. So I'll do that now. 5.625 times 6.022, 10 to the 23rd, divided by 18. And we get 1.88 times 10 to the 23rd atoms, or I guess this would be technically molecules. Oops. Molecules of H2O. And there you go, that's the number of molecules. So it's very easy to find whatever you want through using the molar map. And if you can memorize this and just kind of understand this conceptually, like what you're doing in different places, it makes conversions in stoichiometry really easy. Okay, that about covers all I wanted to talk about with Molar Map. If you have any questions, leave a comment down below. And if you have any suggestions for future topics, also leave a comment. Thanks for watching.